Okay, a very good evening from here, wherever you're joining us from. It's great to have you once again on these webinar sessions. It's the Nigerian Society of Engineers Glasgow branch, and my name is Emmanuel Salifu, the Publicity Secretary for the branch, and it's a great pleasure to welcome you today. Today, we'll be looking at a very important topic, and it's Python programming for engineering calculations and design automation. And we have Dr. Pearce with us, who will be doing justice to this topic. I'll go down through the programs we have for today, but before then, endeavor to interact with us as much as you can. We are a very open branch, and you can reach us on Twitter, or via our email. You can check out our website. You can also contact us through Facebook. And we have a YouTube channel where all of the webinars we've had so far have been uploaded. And just to let you know that this is our 12th webinar since the branch actually kickstarted. So we've gone full circle, the 12th one today. And I think it's a very good note to sustain this.
Maybe that thing can change his mind. Maybe you can.
Housekeeping again before I move further. Endeavor to keep your microphones mute, please. Just when you're invited to speak, you can unmute then, just so we don't have too much distractions when the session is going on. So just for the program rundown, after this intro, I'll be welcoming the chairman of the branch for his welcome remarks. And then I'll invite the speaker, Dr. Pearce, for his presentation. And then you would have the opportunity to ask questions and interact with the speaker based on his presentation and the topic of the day. And thereafter, I'll run through a series of announcements that we have lined up. And I'll call upon the secretary of the branch to give some appreciations before we call it a day. Now, I have the singular honor to invite the chairman of NSC Glasgow branch, Dr. Oluseun Adediran, for his welcome remarks. Over to you, Mr. Chairman.
Oh, thank you, Dr. Emmanuel Salifu. Thank you for that introduction. Thank you for, under the program as well. Dr. Chris, thank you for joining us. Although we've not really spoke like that, but for you joining us today, we know it's a lot of energy prepared for this kind of webinar, sensitive topic, and which I believe is going to be loaded one as well. Wherever you are joining us for, thank you for joining us today. We hope that by the time this webinar is over, and the level of knowledge will increase from one level to another. Even myself, I'm really looking forward to this, because this is not the key thing wherever you go, as far as both the engineering, every corner of the world is all about Python. So I'm really, as a branch, we are really privileged to put this webinar to us tonight. What is, before Dr. Chris coming, the Python as a program is a very sensitive one, where irrespective of, is one of the newest programs we are talking about 80s compared to all the other programming we could really talk about. So for me, gaming, irrespective of what you want to do, the calculations and every corner of the engineering needs this. So it's a privilege that we are putting this to your table today, and we hope you will enjoy it. Without wasting too much time, Dr. Emmanuel, if you can go to the next page. The reason why we are doing this, the pandemic has created the opportunity for us to be doing most of these things online now with the webinars, and you see series of webinars, series of fantastic program here and there. The webinar has created that opportunity, which is awesome. However, I don't want us to forget how do we find ourselves here? How do we find ourselves here is the COVID. And a lot of lives has been lost. A lot of things has gone, the economy has gone down because of the COVID. I just want to encourage us this evening for us to do our part to stop this, for us to do our part to, to continue what we have on our page just now. to make sure we still cover our face. Let's avoid crowd. And I know a lot of different parts of the world, they are putting different ease or restriction in place. Wherever the restriction they put in place in our local community, please let us stick to it. I don't want to waste too much of our time because it's going to be super loaded. I'm now going to hand over to, and also want to recognize all the NSC executives, all the FNSCs. If you have the central executive with us, if you have the past one, we are all recognized, all the chairman of the different branches in the UK, even in Nigeria, our Manchester branch, London branch, we really appreciate you. We are still going to recognize you later on. We just want to dive into the actual program now. Over to you, Dr. Emmanuel. Thank you, everyone, for joining. Thank you.
Thanks very much, Dr. Adediran, for that brief remarks. Yes, there's a question: if everyone is meant to know how to code, how to do programming globally around the world today, because the jobs of the future seem to tilt towards this. Talk less of engineers and engineering jobs. And I think this is a very relevant session for most of us. But to begin, before I invite the speaker, I just want to do a small exercise. I'll be sharing a poll just now. It's totally anonymous. Just let us know your level of proficiency in Python programming, just so we can gauge the room. And what we have, we're about 47 just now, just to see how everyone adds up in this area. Could also give the speaker a feel of what's in the room, and then we can see what the need might be. Great, thanks for responding. Awesome. Just 20 seconds more thereabout, and then stop that. Cool. Brilliant. That's about close to 80% of the votes in. Okay, I'll just stop it at this point. There you go. I think you should see the results just now. Yes? Just confirm if you can see the results.
I can see them. That's very helpful.
Cool.
It's a good idea to run this. Thank you.
Yeah, so we have about 69% who are novices, just like myself. And yeah, 14% who only know about Python as a snake. I found that very interesting. So I guess, Dr. Chris, you have a whole lot to do today to bring us all up to speed, and some experts and advanced people in the house to also support, I guess, at the question and answer and interaction sections. Great. So I'll just stop sharing that, and then I'd introduce the guest presenter for today, Dr. Chris Pearce. He has a very short biography. I'm going to just read out. Okay. Sorry about that. So Chris Pearce is a principal engineer in the design and advanced technology practice of ATKINS Infrastructure Division. After completing his PhD in engineering at the University of Exeter, he joined ATKINS to work in industry since 2014. He has experience in structural design and structural integrity assessments, primarily in the offshore wind and nuclear sectors. His professional interests include structural dynamics, design for strength and fatigue, simulation, and design automation. Please join me in welcoming Dr. Chris Pearce to present his talk. I'll stop sharing the screen and hand over to you.
That's excellent. Thank you very much for that introduction. And thank you also to the chair of the branch for a very important topic there about the circumstances that we're all in. And there are small parts of a silver lining, I suppose, to this, but as you said, we really should recognize the seriousness and gravity of the situation we're in, but at least it's enabled us to have these sort of conversations, so that at least is a positive. So I've got some slides prepared, so I'll share my screen. There we go, screen So please let me know if that's coming through.
Yes.
Yes, that's coming through.
Excellent, thank you. So, yes, Python programming for engineering calculations and design automation. It's quite a wide topic, and I think I was thinking today about how I could help put the use of Python into context, and I think it's already been recognized and very sort of eloquently said at the start of this presentation about how it's becoming increasingly important throughout our industry. So I just wanted to give a little bit of an overview. So today I'll be just introducing briefly, as I said, the aim of this talk, an overview of Python, where we might see it being used in projects. I want to touch on a few example projects that I've used Python in myself during my own work. And then I want to touch on some related software tools that it's good to know about that help make using these kind of tools much more straightforward. I'll be talking about useful modules, and I'll be explaining what modules are later on in a bit more detail, but essentially they are additional libraries that help expand the types of things that we can achieve with Python. And then I want to signpost to some useful resources in case you're interested and you want to have a look later on after this talk. And then I have got a few things lined up for a short demonstration that I'd like to show you as well. So an introduction. So thank you very much for referring to my bio there, Manuel. So just as a summary, I suppose, I'm an engineer by background and by profession. I'm not a programmer. I haven't got a computer science degree or anything like that. But I suppose I approached this topic without very much background originally. When I joined ATKINS, the engineering consultancy where I currently work, I didn't really have much programming knowledge at all. I'd used MATLAB a little bit, which is obviously a popular scientific computing tool at university. But I didn't really come with that experience already, but I was quite keen to learn it, and through a little bit of sort of studying myself and trying to employ it on projects over the years, that skill sort of built up quite a lot to the point where it's become a really sort of key tool in the work that I do day to day in my job. Obviously, I'm going to be talking about Python throughout the talk today. I just want to say, you know, I don't work for Python. I don't work for any of the software firms that I'm mentioning today. But it just has really become an integral part of my work and my current role. So the purpose of the talk in general is to give an overview of what Python is, what it can do, and why it's relevant to engineering professionals such as ourselves. So an overview of Python. So Wikipedia describes it as an interpreted high-level general-purpose programming language. Its design philosophy emphasizes code readability and its notable use of indentation. So those are all technical terms used to compare different programming languages. What that means in practice for us, the fact that it's high level means that it's easy to use and it's easy to learn. It summarizes the commands that it's trying to execute in a high level sort of abstract way with useful commands such as while something is true, do something. Sort of easy to understand commands such as this. So if it was low level, it would be operating more at sort of closer to the machine code of the computer. So you've got programs such as C, which is sort of more low-level code. So what this summary is basically telling us is that Python's quite easy to learn, and also it's quite a powerful and versatile language as well. So why is it useful for engineers? Well, I see Python programming very much just like another helpful tool that we have in our toolbox, a bit like software such as Excel and Word and so on, that we can use in our day-to-day activities. So it can be really helpful for a number of things, such as automating repetitive tasks. It can be used to perform engineering calculations, and it can also be used to control other software. So I certainly think that adopting Python in our sort of everyday work can really help us do things more efficiently if we're dealing with, say, for example, a large number of files, and also tackle new challenges that perhaps we otherwise wouldn't have been able to do. So the pros and cons of Python, I think, compared perhaps to other computing languages. So if we look at the pros first, I mentioned before that it's very powerful and versatile. And it's also, the nature of the language is, it makes it relatively easy to use and to learn compared to a lot of other languages. That's mainly because the language is structured in such a way that it's built into it, that it makes it quite readable and clear in the way that it's laid out. It's also free and open source, which is great. And its popularity means that there really is a large community online with a lot of people using this all the time. Lots of people are able to help out with any questions. I think you'll find that most questions you might come across, if Python throws up an error and something isn't quite working, you'll find that actually that answer will be online somewhere already. Also, due to its popularity, there's a huge collection of libraries online, which are essentially other useful pieces of Python code that have been created by the community that you can freely download, that help you to perform specific types of calculations or specific operations. So they kind of extend the capability of the program, and Python's really strong at this. There really is a huge number of libraries which they call modules in Python language. So cons, there obviously are some cons. I really don't think there are actually too many, which is why I'm quite a fan of Python. But I suppose I mentioned before it's a high-level language, and that by its very nature means that some other programming languages are going to be quicker than it. So for example, C++, that can be a very fast language and is used for a lot of scientific computing software, whereas Python probably would struggle to get to the same computational speed. Now, I've written in some cases here in brackets because I really want to qualify this con. I think, firstly, it's important to recognize that there probably aren't that many cases where the level of difference in speed that we're talking about is really going to be that important to us. Occasionally, as engineers, we might need to do very large calculations, dealing with many thousands of files or input data of various types. Now, Python can get through that pretty quickly. It certainly can get through it quicker than us doing anything manually. Of course, it can certainly get through those sort of calculations much quicker than, say, trying to do something in Excel. But if we really are pushing the boat out, so to speak, and we really are dealing with hugely complex calculations, then perhaps by that point Python isn't the right choice, and maybe we should be looking at something like C++ or so on. But often that kind of thing's outside the remit of what we would do as engineers anyway. I would say that might be the kind of thing where actually you might need a software developer to create some specific thing to try and solve that problem for you. I searched for cons, Python cons online. I couldn't find too many. Another one apparently is mobile computing. That's not something that affects my work at all because I'm not a software developer, but apparently the language isn't actually that well supported by mobiles if you wanted to write some software for your mobile phones, but that's probably not something that would affect us very much. So where might you use Python on an engineering project? Well, I guess if we think, I suppose before looking at the asset lifecycle, as was mentioned in the introduction, I very much agree that the engineering industry is going through what's sometimes called a digital transformation at the moment. And I guess the purpose of that really is twofold. So it's to better make use of technologies and data to enhance the efficiencies of the work that we do and to generate new opportunities by being able to solve problems that we otherwise couldn't, for example. So programming is a key enabler of digital transformation, particularly an aspect of that which is called, sometimes called design automation, which is obviously automating parts of the design process. And it's becoming an increasingly valuable skill within engineering firms. So I wanted to highlight that it's important for engineers at all levels to understand programming in a manner that's appropriate for their role. And what I mean by that is I appreciate that an engineer in a very senior position who might be looking after you know, large or medium projects or technical teams may not be involved in actually coding solutions to a problem or an engineering calculation themselves. But I still think that it's really important, as I say, for all levels to understand what the impact of these kind of disruptive technologies are going to have on the industry. So if we refer back to our senior engineer as an example, I think it's important for them to know what Python is capable of, what other members of their team might be able to deliver using programming, how they could automate various aspects of the design process. Whereas other members in that engineering team, for example, I think, you know, it is very valuable to have members who do have, you know, very much a practical and hands-on skills when it comes to programming and being able to automate certain aspects to improve efficiency when that kind of opportunity is there. So if we look at the asset lifecycle, then I've just really simply broken it down into design, deliver, and operate. So if we look at design to start with, this is just a simple sort of process map of the design process. There are many ways of thinking about this, of course. So where might Python possibly find a home here? Well, I've indicated that by these little computer symbols. So for example, in earlier stages of design, we might be looking to literally write a program to perform engineering calculations. Now we could do those in many different other software packages or just by hand. But if we've got really complex ones or really lengthy ones, or we need to do them many thousands of times, for example, then we'd want to automate that. We may be looking at generative design or design optimization, where we use software to automate the process of trying out many different designs to help decide, to help inform our design process. Or we might be looking at machine learning, which is obviously very much a buzzword at the moment, but I think through things like Python, which is very widely used in sort of the machine learning communities, I think that is becoming democratized quite a lot in the sense that I think machine learning in the coming years will be much more accessible to all of us. We may be wanting to use Python to automate CAD or CAE software, so that may be for drawings, or maybe scripting some of our other engineering software like finite element analysis software, or many other packages which are scriptable using Python. Later on in the design process, we may want to help automate analysis of different designs that we've produced. Again, we might want to perhaps build some automation into our drawing deliverables, so perhaps automating CAD in various ways. And also I found that sometimes it's quite interesting to think about new ways that you could present results to your clients, for example. So coding is a very useful skill if you want to map design data or calculation data to 3D models. That may even be something that you could feed into, as I say, other novel ways of communicating results or communicating models with your clients. So even as far as VR, for example, I've seen done, and we have a VR suite in ATKINS, for example. So if we continue looking along the asset lifecycle, so a stage that I've just called deliver, which is more to do with management of the project, ensuring that we can go through all those technical steps that we need to go through. So coding actually is finding increasingly a home in this side of engineering as well. So project administration, we can, for example, automate drawing logs or document changes. We might need to search for information in a large number of documents, and we might want to organize files and folders. If we have a large number, then being able to do that in an automated manner is really useful. And then finally, operate. So we've delivered our asset. It's currently in the hands of the client, and it's in operation. So really hot topic at the moment is this aspect of what's called digital twin, which is where you can combine, I suppose, conventional asset management with the recent increases that we've seen in our capabilities in terms of automated data processing to create what they call a digital twin, which is obviously a sort of digital version of the physical asset. So coding can be really useful in the sort of operational side of things as well. You might want to gather or process data for monitoring your asset. That would allow you to perform structural integrity assessments while the asset's in operation, and digital twin I'd already mentioned. So just a few examples of where projects that I've been involved in myself, where Python has featured really heavily. An example in the design phase for seismic design of complex structures with large pieces of equipment in them. So Python was used in a number of projects recently to automate what is quite a time-intensive calculation, where we calculate the dynamic response of pieces of equipment in buildings if they were subject to an earthquake. Just some examples of large pieces of kit in the types of structures we're talking about there. So this is just to give a feel of the type of calculation that we're talking about. So if we have a structure on the left and we have an acceleration time history that is caused by the earthquake that's affecting our structure, that obviously is transmitted through the structure and is modified and amplified as it travels up the structure. And then we have various pieces of equipment sitting on the floors and it's important for us to be able to calculate the dynamic responses of those as well. So that's quite a time intensive set of calculations if we're doing that for many areas in these large buildings. So that was really helpful to be able to automate that with Python. Another example, if I just add these images here. So an example from the operational phase is in the offshore wind industry, is we've used Python to process large amounts of monitoring data collected by strain gauges on offshore wind turbines. So this is just a series of diagrams here showing where those strain gauges are located, are typically located in offshore wind turbines. They're capturing strain data 24/7, and obviously a huge amount of data is gathered. So it's really useful to be able to process that and use Python to allow us to take that data and perform calculations to predict the damage that might be occurring on the structure, and ultimately the fatigue lives of the structures. So I mentioned earlier that another sort of powerful aspect of Python is scripting other engineering software packages. So obviously Python can be used to perform calculations just by itself, but we have a lot of really useful engineering CAE software that we use all the time within our work. And quite a lot of those packages are scriptable, which means they can be automated using Python commands. So it's a popular language for that. I mean, obviously, lots of engineering software have their own scripting languages, or they may use other languages like C#, for example, but Python's quite a popular one. So some that you can interface with Python are the ATKINS finite element software, things like popular GIS packages, several Autodesk packages, and other CAD software such as Rhino 3D. If we're talking about software that's sort of related to Python, I thought it was also worth mentioning what are called integrated developer environments. So you can create Python programs just in a text editor, but it's really helpful to have what's called an IDE as well. So these are specific pieces of software designed to make programming a bit easier. So they often contain features like this. So they often have parts of the program that you would call an editor, which basically is just a text editor where you can write programs. They'd have a part of the program called a console, which is just like your standard Windows console. So it displays useful information. That's where error messages are printed, for example. And what I find very useful is something called a variable explorer, which as your program's running, it will show you it allows you to get a view of what your program's doing while it's running, and it's really useful for being able to inspect what's going on. I'll talk a bit more about that later during the demonstration and hopefully make it a bit clearer. So just to mention, in case you wanted to have a look at for these later within your own time, some popular IDEs are Spider, Visual Studio Code, which is by Microsoft, and Jupyter, Jupyter Notebooks or Jupyter Lab you may have heard of. So modules, I also wanted to mention some useful modules. I did say at the start of the presentation that these are libraries that give additional functionality to Python. So they're maintained and developed by the online community. In the vast majority of cases, they're freely available. And there are some central repositories where these can be easily downloaded. So popular ones are PyPy and Anaconda. Python's really popular, so I guess because of that, there really have been a very large number of powerful libraries developed over the years. and quite often for very specific purposes as well. So if there's some specific type of task that you're trying to accomplish, you may find actually that there's a library for that that will allow you to do that. So useful examples for engineers, in my opinion, are things like NumPy, which allows you to deal with large arrays of numbers and matrices, so you can do matrix calculations. SciPy, which adds scientific computing functions, so things like linear algebra, integration, Fourier transforms, etc. Matplotlib, which is for creating plots, so that's really useful. OpenPyXL allows you to interface with Excel. SymPy, which adds symbolic computing, and something called Pint, which adds physical quantities. So that's really useful to add units occasionally. If you quite often programming languages will just deal with the raw numbers, but if you actually want to include, if you want to attach units to those numbers, so just standard SI units, for example, that can often be quite helpful. Useful resources that you may want to have a look at later. So Anaconda is a very popular scientific computing program that's freely available, freely downloadable if you're an individual user. If you're using it for, if you're using it as an organization, I think you need to purchase a commercial license, but it's free for any individual user to use. It comes bundled with a lot of the things that I just spoke about. So popular IDEs like Spider and Jupyter, and modules like NumPy and SciPy and so on. Learning resources. So this talk obviously isn't it's not really a Python tutorial. I'm sort of giving an overview of its importance and relevance. If you're interested in learning Python, then there really is so much content freely available online. I did highlight some paid courses as well, just because these are quite high quality ones if you're interested in that. But I would say as well that there's a huge amount of really good free training content on Python on the internet. So if you want to learn, then yeah, just have a look. Realpython.com have some great tutorials, and I definitely recommend having a look at this book, Automate the Boring Stuff. It really is a great Python book, and you can read that for free on the author's website. Great, so that was the end of the slides. So if I can go back to just my desktop, and then I'll go through a demonstration or two, and then I'd be happy to answer any questions at the end. So I think the first thing I'd want to do is just open up my IDE, and the IDE that I use, the integrated developer environment that I use, is Spider. So I'm just rearranging my screens here. So I use Spider. I think that's quite good. Hopefully that's coming across okay. Do please shout if it's not clear or if it's not coming across, but otherwise I'll proceed. So this is not a tutorial, but what I wanted to do is just for the first few minutes give a really basic overview of the sort of core concepts, I suppose. So this is my IDE. This window here, if you can see my cursor, that is the editor window. It's just a text editor. You can write whatever you want in there, and that will execute. If you then click run, that will execute that as a Python program. So what I'm going to do is I'm going to type in a comment, so my simple program. Now, I've started that with a hash symbol, which means that means it's a comment, which means that the Python interpreter will skip that. So you can, those are really useful because you can add notes to yourself about what your program's doing and so on. So let's see. So let's write another comment. I'm going to just tell myself what I'm doing. Define a variable for input data. So let's define a variable. So you do that just by typing any name like this. I mean, it needs to, there are a few rules. It can't begin with a number, for example. But if I write something like input variable and then the equal sign, I can assign that anything I want. So let's assign it a number. So a variable is just like a container. So apologies for everyone who already knows this. I think it's good to just give a brief introduction of the real basics and then sort of build up from that. But a variable is just like a container. It's like a bucket, and those get used by the program to store information and perform operations on those. And whenever we use the equal sign, we're assigning some information to that. So that's obviously just got the number 5 now. So if I click my play button up here, that's going to run the program. Now, this is a really useful window over here. This is my variable explorer. And I said that can sort of tell you what your program's doing. So that's showing me now that within my memory, I have one piece of information stored at the moment. It's called input variable. That's the name that I gave it. And the information it contains is obviously just the number 5. So let's perform a calculation. So the rules for mathematical operations are all of the basic symbols that you'd expect. So if I do 2 times input variable, let's say, and then I'm going to add that again, and 2 asterisk symbols is the Python syntax for an exponent. So what I'm doing is I'm adding on the square of my variable there, and let's subtract something as well. So if we run that, then that performs our calculation, and it's assigning it to another variable. So we've got our result here, and that's giving us the number 28. So we can also equally work with text. We can work with lots of different data types, but the 2 most basic are obviously text and numbers. So in Python, text are called strings, as in a string of characters. So again, we'll assign it to something. So if I create a variable called text1 and assign it a string calculation, you can see that the string is any text that's designated by quotation marks. So let's create another string called text2. And then what you can do actually is, if we use our add operator, just as if they were numbers, and assign the output to text combined, that's actually going to join those 2 strings together. And we can check that by using a really useful command called the print command, which is often used to sort of output useful information to your console window, which is down here. So if I run the entire program now, you can see in my variable explorer what all of the new variables I've created contain. And actually, if we look at our console window down here, you can see that it's printed to those 2 strings joined together. So that wasn't quite a tutorial. That was just a sort of very basic introduction to some of those concepts. So if I now move on to a bit more of a demonstration about again something that's quite introductory, but I think it's good to sort of get a bit more feel about how Python works and what it is. So I'm just going to save my notes over there. So let's say that we're playing a game of Scrabble. So Scrabble, obviously the word game where you're trying to spell different words on a board with different points, and each of those letters within the word that you're spelling has a different number of points associated with it. So I've just copied in 2 lists here. Now, a list is a different data type within Python where you can store separate pieces of information separated by commas, and it's kind of like a column of data in Excel, for example. So we've got 2 different lists and they correspond to each other. So my points list has all of the points associated with the letters in the alphabet. Now let's say that we wanted to create a little tool that would be useful for us during our Scrabble games, a little function that can calculate the number of points that any letter, that any word would have as its total in the game. So what we can do is, I'll just copy this in. I can write a new line where I'm using the function input. Now, input is a built-in function within Python, and you'll see when I run this that what it's doing is it'll ask us a question in the console window. It'll say, well, the question we've defined here, it will ask us to enter a word, and then it will take anything that we type in to the console window and it will assign that to our input string. So let's just run that now. And you can see in our console window down here, it's asking us to enter a word. So I could enter in cat, for example. And I've just hit enter, and you can see our input string now has the word cat in it. So if we want to calculate our Scrabble score, then we need a bit more code. So what I've just entered here is the code that allows us to calculate that score. So first of all, I'm starting out with a variable that will hold our total score, and that starts by having a score of 0 in it. Then what we do is we define what's called a for loop. Now, I'm probably going through these concepts probably a bit quicker than a normal tutorial or lesson that you might find online. So apologies that it's not a proper lesson, but just showing you some of the structures that Python has within it. So it's a for loop, and what that does is it allows us to say, well, okay, for any word that's stored in our input string, just loop through all of the letters one by one. And then what we can do is we can look at each of those letters one by one, and we can then consult our letters list, work out which letter we're looking at within that list, and then cross-reference that against the points list. And then we can just add up the points as we go through the word. And then again, we're using the print command to print out what our total score is. So that's our complete program here. So if I press play again, it's asking us for a word. So I might type in engineering, and it tells us that our total score is 13. So that's sort of another kind of introduction, I suppose. Let's look at something a little bit more engineering related. And what I'm actually going to do for this one is jump across to a different IDE. And it's not to be difficult, but it's sort of to, I suppose, highlight that different integrated developer environments have different strengths depending on what you're looking at. So I'm going to open up my Anaconda console, which I told you about in the presentation. But that's really useful because it comes with all of these things preloaded on it. So that has, for example, Spider, and it has Jupyter Lab, which I'm going to be using here. So there's my Anaconda. I'm going to launch Jupyter Lab, and I'm going to navigate over to a short program that looks at a cantilever beam. There we go. Okay, so I put together this brief example a short time ago. And what this uses is it's demonstrating a few things. It's going to be using matplotlib to do some plotting. It's going to be using Pint to handle scientific or physical quantities, so units. And it's going to be using SymPy and NumPy to do some calculations. And SymPy specifically is for symbolic calculations. So that's really useful. So this first, the way, and apologies to confuse you with another IDE all of a sudden, but this is structured in a very similar way. So it has our variable explorer over here, which doesn't have anything in it at the moment. And the way Jupyter works is actually our code, our different blocks of Python code are stored in these different cells. And it works in quite a different way in that you can evaluate one cell at a time and go through your calculations. So Jupyter is quite popular in academia, for example. You can write calculations that are quite well formatted and easily legible, and you can share those with your colleagues. So if I evaluate the first block, that's just reading in these different modules that I was talking about, and that's quite important because they're imported in Python. Oops, someone's drawing on my window. Can I clear that? Oh. Thank you. Thanks. So the next block, what that will do is it will define some symbolic symbols for us. So we need E for Young's modulus, I for second moment varia, L for length, and so on. We've got Q for our UDL running along the top of our cantilever that we're looking at here. So let's define a function that represents the shear force along the cantilever. So I've entered in what that function is. It's obviously QL minus QX, and that's printing it out in symbolic form down here. So this is quite different from most computing languages where you aren't dealing with symbols and algebra. You're just using the numbers much like you would a calculator. So again, we can define a function for moment at any position x as we move along the cantilever. So what this is doing is it's reading in our shear force, and it's translating that to the bending moment function at any position x. So now that we've got our bending moment function, what we can do is we can use the relationship between curvature of a beam and the bending moment and the flexural stiffness to define a function that solves our standard beam equation for us. So what we're doing in this stage is it's differentiating, it's twice differentiating our moment function, and it's returning to us our expression for the curvature along the beam. Then what we can do is integrate that curvature expression, and what we get here again in symbolic form is an equation for the deflection. Now that's all just using SymPy, the symbolic calculator. What we're doing in this part of the code is actually reading in, we're assigning some physical quantities with units. So the way that I've got it written here is UR stands for unit registry, and then we've got M for meters, Pascal, newtons, and so on. So that allows us to actually create a function based on our deflection expression, and we can return what the greatest deflection is based on the inputs that we've given it in meters, and you can see it's printing the meter there. And finally, we're just using a simple function from matplotlib to plot our results and to plot our deflection as we move along the beam. So that's quite a simple example, but obviously you can expand on that when you've got more complex cases, but it's just to show that this is very much related to everyday engineering calculations. So let's go back to Spider, and the final example that I wanted to show you is a simple finite element solver. Now, obviously, if you're doing finite element analysis, so computational structural analysis in your day-to-day work, you'd probably use dedicated software for that. I'm not expecting Python to be that practically useful in terms of performing those calculations itself, although it is really good at automating them. So like I said, we use Abacus in our team, and that's scriptable with Python. So actually we do that all the time. We sort of automate Abacus and control it using Python all the time. But just as an example of, again, a practical engineering type of calculation that Python can accomplish, let's use it as a finite element solver. So if I'm gonna open up the first part of this program, which is something I've called element library. And you can see, I won't go into much detail here, but just really sort of high level, you can see that we use the def keyword to define specific functions. All of this in green is a comment, so that's just information for me or for the user of the code about what the code's doing. So that doesn't get interpreted by Python at all, it's just a comment. And you can see we're starting to do things like defining a stiffness matrix for a truss element in this case, and defining a transformation matrix. And again, we're doing something similar down here in a different function for a Euler-Bernoulli column. So again, it's a stiffness matrix and a transformation matrix. So these are some very simple element definitions. Then we have a second part of the program and a second file. And what this does is it's using NumPy, it's using matplotlib, and then it's reading those functions from the file that we were just looking at before. And it's making use of those by, I won't go through this code. It's actually quite a short program. What that's doing is it's pulling together, it's reading the information describing any kind of truss or beam system that we've defined in a separate file. So we might have an input deck like this, where we say, let's define 3 nodes representing 3 different points in 2-dimensional space. So this particular input deck has got those 3 points at 0, 0, 10, 0, and 10, 10. And what I'm doing here is I'm just replicating this very simple 3-element triangular truss. It's a very simple case. And I'm just replicating that here in this input deck. So we define some section properties, some physical properties to those different truss members. We define our boundary conditions, and then we define our loads. So that's the loads, for example, are both applied at node 3, which is this node at the top. We specify our direction. So direction 1 is horizontal, direction 2 is vertical, and we specify the magnitude of the load that we're applying. So this code, in the slightly longer Python code here, what that's doing is it's interpreting our input deck, and it's using the stiffness matrix definitions that we'd put together in the other file to create an overall stiffness matrix defining the system, and then it can solve that. And finally, at the end of the code, if I scroll all the way down again, we're using matplotlib to plot the results. So if I run it for this simple case, what that's done for us here is it's generated a figure down the bottom. I can open that up, and you can see that again, it's what I've asked it to do here is draw that simple truss for us. So that's the light blue line. It's put some very basic symbols representing the boundary conditions, representing that horizontal and vertical load. And then the orange system is the predicted deflected shape based on that, the load that we were analyzing there. So So that's a really simple case. I have a few other test cases for slightly more complex things. So if we open up this one called bracket truss, and I run that, again, it's very quick. That's showing we've got sort of a, almost like a PFC, almost like a sort of parallel flange shaped type bracket truss here, but it's just made of truss elements. And we've got 3 loads representing almost like a distributed load pulling that away. This is obviously exhibiting very large deflections because I've given it quite weak members here, but it's just showing you quite a sort of simple calculation and the type of thing that it can do. And finally, I've got a bit of a taller tower truss type structure as well. That again just solves really quickly. So if I just run that, we can see we've got quite a tall structure with a very weak load at the top, but that's showing that because of that moment arm, it's deflecting quite a lot. Great, okay, so in terms of the demonstration, that was everything that I was hoping to talk through today, but I'm very keen to take any questions that anyone might have.
Thank you so much, Chris, for that talk. I think it's quite overwhelming just now, and there's a whole lot to process. But I think everyone from the novice to the advanced users must have 1 or 2 things to pick out of this. And I think we're going to be having lots of questions coming on in the interactive Q&A session. So I'll just thank you very much. And then I'll hand over to my colleague who will be handling the Q&A session so that he can moderate that session and get you to respond to the questions that people might have just now. I'd invite my colleague, Engineer Sharp, to take over the Q&A session. Engineer Sharp.
Okay. Thank you very much. Thank you once again. Mention.
Okay.
Please, if you have a question, I've seen 1 or 2 dropped in the chat room. You can raise your hand electronically. If you go to the chat room and then raise your hand, you can, if you want to speak and verbally express your question, you'll be called up to do so. Otherwise, you can still leave it in the chat room in text file. I've seen 1 coming in or 2. The first one says, is Python also relevant in the power electronics kind of calculation or engineering work? So what would you have to say on that, Chris?
Sorry, I didn't quite catch. What was the concept that was relevant in power electronics?
Python, can it be used? Can it be used in power electronics?
Oh yeah, most definitely, yes, for sure. I mean, so as an engineer that works in a more sort of civil structural field, obviously you can see my examples were deflections of beams and that kind of thing. But yeah, I think it's heavily used in that field as well. I think, yeah, anything that you've got those scientific computing functions inside Pi. You can use physical units using some of the modules that I've mentioned. I think it would be applicable in that area as well.
Okay. Well, someone is asking, what's the real difference between using MATLAB and Python?
That's a good question.
What's the real difference, or perhaps benefits?
Yeah, that's a good question. Yeah, I think one key advantage of Python, I think, is I've got a few things to mention, but I'll start out with the cost. So MATLAB, the licenses for MATLAB are, if you're looking at a commercial license, they're quite steep. That's quite expensive. Now it's a really good piece of it's a really good tool, definitely. But I'd say that actually where we are with Python at the moment is it can compute at the same kind of speed as MATLAB. There really is not much difference in it at all. I think in some cases I found Python to be quicker, in some cases I found MATLAB to be quicker, but yeah, it's much of a muchness really. I'd say also where Python really excels is that strong online community. So like I mentioned, there's so much support out there. Any sort of problem that you might have come across, someone will have answered already online. And all of the modules that you can find, there'll be a function perhaps that somebody's already written to help you in any sort of particular type of project that you're working on. So I see that as a real differentiator. But you know, equally MATLAB is really useful, and it's a very sort of similar type of tool, definitely. So yeah, I'd say there's not too much in it.
Okay, thank you. Can Python handle animations?
Yes, yes, I'm pretty sure it can. It's not the kind of thing that I've done myself before, but people create, I think Matplotlib can do animated plots as well. People use Python to write games as well. So yes, I'd say almost certainly yes, but it's not the kind of thing I've done myself.
Okay, thank you. I will invite Yinka Bamiro, whose hand is up, to unmute himself and present his question. And after him, Engineer Razak SA will also unmute himself and ask a question. Thank you.
Hi, can you hear me?
Yes.
Oh, okay. Yeah, good presentation. This is Dr. Bamiro. So I typically use Python. You know, you talked about Abacus. I do CAE and CFD. I use it a lot for automation and distributes the Python script to engineers to use. And now with regards to graphical user interface, right? Do you delve into that area? And then if you delve into that area, what's your choice? Is it Tkinter? Is it PyQt? Is it GTK? And let me just pick your brain. What your best choice is there? Thank you.
Yes, it sounds like we use Python in very similar ways on that. So it would be good to share some thoughts. Although unfortunately, I have to say that when it comes to the graphical user interface, it's not something that I've used very much. You can see from the examples that typically we write things just in sort of open code files. I think quite a lot of the engineers in my team are very familiar with Python, so we tend to just share, you know, raw code files like this. I've heard, I mean, I'm afraid it's not first-hand experience, but several people in my team have used PyQt, and they've had positive experiences with that. But I'm afraid that's all I can say on that.
Okay, thank you.
Thank you. Engineer Razak.
Yeah, if you can hear me, I just want to know, maybe Python can be applicable to in the civil engineering realm in terms of prediction, future prediction, probably on a construction, in terms of probably load stress on a construction, or load I don't know how to put that, too much load on it, as in maybe it can project, I mean, it can give a future prediction on when next a major maintenance can be carried out on such designs. What do you think about that? Or what can you say about that?
So in terms of a construction, do you mean in terms of the operation of an existing building that's in use, and when that might next need maintenance?
Yeah, exactly. That's what I'm saying in terms of maintenance of future projection on maybe stress, action of stress on a construction or a building generally.
Yeah. Yes.
Can it give a brief?
Engineer Razak, your line is breaking up, but we have the I think we've got the question you're trying to put across. Can Python be used to make some predictions based on the load factors when maintenance might be due?
Yeah, exactly. That's what I'm saying.
Yeah, that's a good question. I'd say that's probably a question that's more sort of directed towards that kind of more general theme of asset management. And I'd say it's not necessarily a Python question, but Python could be a useful tool for that. So yeah, that's an interesting one, and I think it's an important area. And I think we'll probably see a lot of development in that area in the future. I agree. I think the important thing with that is you need to think about where you're getting your data from. So the example I used in my presentation was on the offshore wind turbines. So you always need to have that data from somewhere. So we were using strain gauges in that example, but there's lots of different interesting monitoring techniques you could use. For example, you could use sort of digital images, and there are techniques that can calculate the stress from basically a camera taking repeated photographs of an asset. So that's an interesting one. Then once you have that information, the other question is, well, how are you going to use that to predict any future issues, for example, based on stress cycles leading to fatigue or so on, like you touched on. So again, there's a few different choices that you have there. And I think machine learning is becoming increasingly popular. It's actually something, when we were looking at the wind turbines, we decided not to use machine learning specifically because we had a good understanding of what that physical behavior was. I think the strength of machine learning is actually when you have a very large data set of high quality data, then you can make predictions without necessarily having to understand what the underlying cause is. But yeah, it's a broad question. It's a good question, and I think there's a lot of research in that area, I think.
Okay.
Thank you very much.
Yeah. In terms of interface with other useful tools out there, the likes of several programs, FEAs and CFDs, how is Python really easy to talk to a lot of them?
Yeah, I think it depends on it obviously depends on the program. Abacus was one that I mentioned and was also mentioned a short time ago. Abacus has got a really good interface for that, so that makes it quite straightforward. I think all of the ones I'd sort of flashed up in my presentation, so if I just jump back to that briefly, these ones have sort of dedicated functionality for Python scripting them.
Yeah.
I think if you're talking about software other than something that's already has Python as a scripting language, or it has Python as what's called an API, so an application programming interface, then there may be routes to do it, but it would probably be a bit more complicated, and it would very much be program specific.
Okay, thank you. Right. Like two more questions, and
yes, my hands are up. I've raised up my hand, please.
Okay, go ahead.
I have my hands up.
Okay. Go ahead, please.
Hello, sir. Can I talk? Yeah,
go
thank you
ahead.
very much. It's a very well delivered lecture by Dr. Chris, and I actually appreciate your way of delivery. Now, I'm very vast at using Fortran, and the way I've seen Python seems to be slightly very close to Fortran. Now, how can somebody who is new in Python, but relatively have that expertise in Fortran, quickly grab Python? That's number one. Now, what advantage does Python have in comparison to Fortran? Then number three, how can you use Python to study underground subsurface flow in terms of CFD? Thank you.
So I think to answer your first question, yes, Python has got some aspects that are very similar to Fortran. That's a good point, and that's true. And I think the same is also true of MATLAB. My understanding, and if anyone else on the call knows, can confirm this is true. I think basically the way that MATLAB deals with matrices is basically taken from Fortran. So it's exactly the same or very similar syntax and same way of doing it. And then going a step further, if we look at, now where was the relevant slide? If we look at NumPy, which is a really, really popular module and is probably the one that we use most often. That in turn is based on MATLAB. So if you've got any MATLAB experience, I think it's it makes it a lot easier to get comfortable with Python because it's using that same syntax. So if I go back to Spider and I quickly open up the element library, this kind of matrix, the way of laying out the matrix and so on, is really similar to MATLAB. So hopefully your Fortran knowledge will also be really useful in that regard as well. And I'd say, in terms of tips of getting used to it, I'd really just say, download Anaconda, open up Spider, and start playing around, because I think it'll probably come quite quickly to you. And I think a lot of your knowledge already will be really useful. And perhaps you might want to have a look at Automate the Boring Stuff or any of these that I'm suggesting here. They're good resources. Could you please remind me of the other parts of your question?
Can it be used to do some subsurface CFD calculations?
So CFD is not the type of calculation that I've done myself. I don't tend to work in that area. I'm not sure whether there are any commercially available CFD codes that can be scripted with Python. Hopefully there are, but you can see that I have not included any in my list because I'm not familiar with them myself. In terms of actually then, rather than scripting, if you wanted to do the calculation within Python itself, kind of in a similar way to the FE finite element calculations that I was doing within Python. Again, it's something that I don't know because I've not used it, but there are lots of finite element Python modules that have been created by the communities, and there are some that have been developed to quite a high level. So there's one called OpenSeas, for example, which has a really large element library and an active community, and that is it's a Python module or series of modules perhaps. It's Python code, but it's ended up, I suppose, becoming really powerful and probably has a lot of similar functionality to, say, something like Abacus or commercially available FE software. So whether there's an equivalent in CFD or not, I can't say for certain, but it's definitely worth having a look.
Okay, thank you very much.
Engineer Sharp, will you mind to I think Dr. Inka Bamiro is online. What he was explaining the earlier on seems to be valid with that. Dr. Inka, will you mind to step in and to support that part, please?
Yeah, like Chris rightly said, right? You can use Python invariably for CFD, you can use it for finite element analysis, but it's not the right tool for that kind of job, right? Because it's going to be slower, right? So what people typically do for the heavy lifting of computation and things like that, you tend to use programming languages like C++, Fortran, right? And even MATLAB itself, it uses Fortran, LIMPAC libraries and things like that, right? But if you want to automate tasks of setting up your models and submitting it and things like that, that's where Python plays a heavy role. For the computation itself, you want to use, Fortran, C++, and so on and so forth, right? But for generating the input files, the pre-processing and everything, that's the beauty and the power of what Chris is presenting, like Python and things like that. Okay. Yeah, that's my input on that. And Chris can add to that, yeah.
No, I definitely agree, yeah. It's very well put. And I'd say often as a user, I tend not to interact with things like C++ directly or Fortran directly, but I know that they're the engine behind some of the more powerful commercially available software that I'm using, like Abacus and so on. But as you said just then, I suppose what I see as a really powerful aspect of Python in sort of our day-to-day work is exactly as you said, so preparing those models and post-processing the output as well. But I did just want to mention that I think there are, as I said, that if you really are interested in finite element analysis within Python itself, it's a good question. And again, if speed's an issue, probably isn't the right tool. I completely agree with you. But if you're interested, there are some projects out there where people have been looking at that as well. But yeah.
Okay. Thank you very much, everyone. I'll hand over to my colleague Emmanuel again. I think that's all the questions we've seen come through.
Sorry, Engineer Sharp. I think we have the Vice Chancellor of Landmark. He raised up his hand earlier on.
Oh, sorry about
Professor, I don't
thought
know.
he presented his question already. Yeah.
Thank you. Mine is not of a question. You see, I'm one of those that feel the novice chat, and that is why we were quiet to allow the experts to talk, just to appreciate Dr. Chris for the simplicity of the delivery, and also to thank NSC Glasgow for helping us to build our capacity in this area. The nearest I heard of Python is from my son, who is reading electrical and electronic engineering. But tonight, at least we are no longer novice. We've heard about the fundamentals and the basics of Python. It's left for us to go and improve on it. So once again, we want to thank you for this opportunity.
Thank you. You're very welcome, and it was a pleasure to speak today.
Okay. I'll hand over to Emmanuel.
Great. Thank you very much, Engineer Sharp, for handling that session. And many thanks to you, Dr. Chris, for the presentation and for this interactive Q&A session. Just as the professor, the Vice Chancellor of Landmark University has just said, you've lifted many people from the novice stage to what would be pre-intermediate stage, I would say. I think we also have enough tools now to work with and begin to develop capacity in this area. Thanks to all who have asked questions, who've interacted. Thanks to Christopher Ibe, who's been sharing links on how to download, and also some other questions that were answered in the chat box. Thank you so much. And thanks for all other experts who've been able to chip in their voices to interact with these. We appreciate you all. And I believe that everyone who's attended would have something to take away from this. And people who will watch the videos over and over again would also learn a lot from this. Thank you very much once again. I'll go now to okay, skip to the
engineer Dr. Emmanuel, can I quickly just recognize few people before we dive into announcement? And I would like to recognize the engineer Margaret Oguntala, FNSC. That's the former three-time vice president of the Nigeria Society of Engineers. Will you mind to unmute yourself, ma, and give your remarks, a quick one, ma? Thank you.
Thank you very much for giving me the opportunity. Like has been earlier said, at least I've had the opportunity of moving from the novice stage to the next level to intermediate. Not quite intermediate now though. So, but I guess that I can now, at least I can build on what I learned today. So I must congratulate the guest speaker and our very active Glasgow branch for bringing this to the fore and ensuring that we know a bit more about Python than the snake. Thank you very much.
Oh, thank you, ma. Thank you for joining us. And also, I would like to call on Engineer Olorunfemi, FNSA. Engineer Olorunfemi is the former, one of the past presidents of the Nigeria Society of Engineers. And will you mind to unmute yourselves and give your quick remarks? Thank you.
Thank you, Sean. Thank you, my brother, my bro, and my chairman. I belong to the group of the last two speakers. Now I know that it's not only the one that strikes in the bush that is called Python. I've had it several times. I said, why should I go and be learning about Python when I don't want to be struck by Python? But quite frankly, the simplicity is very profound. And even if some of us cannot learn it again, or at least we feel comfortable looking at what people are doing. Chris, great job. Glasgow branch is a great thing you are doing, leading the pack with the two offshore branches. And we, the Nigerian branches, we are very, very hard to catch up. You've awoken us, and there is a great development. Correlate Glasgow branch, and I thank every one of my colleagues here at the meeting. Let's keep the interaction on. Let's keep growing. Let's keep learning. Thank you very much for the opportunity to say a word or two. Thank you.
Oh, thank you, sir. Thanks for joining us. Over to you, Dr. Emmanuel. Thank you.
Thank you very much. Thanks so much for that. So I'll just run through the announcements we have. And first up here is just to encourage members of the branch to log onto our website and register properly so that you can enjoy the very unique and different benefits aside for just members of the branch. And also to say that we have the branch general meeting coming up by the end of this month on Saturday, the 31st of July, 2021. And it's by 5 p.m. The link to join is there, and this will be circulated across all of our social media platforms. And also to highlight the fact that the NSC National will be having this National Infrastructure Summit 2021. The theme is towards a sustainable infrastructure development, maintenance, and management in Nigeria. This has been hosted by the national president himself, Engineer Babagana Mohammed, FNSC. We had the privilege of his presence just a while ago, but he dropped in briefly and left. He will be hosting this special program, and the speakers are there on that flyer, and there's a Zoom link for us to join online if you're not able to make it to Abuja to be part of it at the Nikon Hilton Luxury Hotel. Also, this is from our sister branch, the NSC London UK branch. They'll be having a webinar next Saturday, the 17th of July, 2021. The title they'll be looking at is From Civil to Human Engineering, From Civil to Human Engineering. And Dr. Kunle Onabolu will be the speaker at that event. It's 2 p.m. UK and Nigerian time on Saturday, 17th of July. That's next Saturday. And the joining details are there on that flyer. And also other sister branch, the Nigerian Society of Engineers Manchester branch, would be hosting their webinar on the 30th of July, Friday, the 30th of July, 5 p.m. They are looking at jumping spiders and flying bees, enabling the next generation of bio-inspired micro-robots. Quite interesting topic there to be addressed or taken care of by Dr. Mustafa Nabawi of the Mechanical Aerospace and Civil Engineering Department, the University of Manchester. Friday, 30th of July, 5 p.m. And lastly, just to highlight that the Council for Regulation of Engineering in Nigeria will be having the 29th Engineering Assembly. It's an assembly for all registered engineers, all engineers registered with COREN. And this will be holding in August, 9th to 11th of August, 2021. It's at the International Conference Center in Abuja from 9 a.m. daily. We are encouraged to register and participate in this very wonderful event. I see some hands up, and I was going to invite the secretary for appreciation, but I think, oh, okay. All right, I think the hands have been lowered. Right then, so I'll just invite the secretary of the branch, engineer.
My hand is not lowered, though.
Oh, okay.
My hand is not lowered either.
Right, okay. It was up and then it lowered briefly. Okay, right. You have a minute or so to just say what you have to say then.
Yeah, I'll go after.
Okay, right.
Please go ahead.
May I speak first? Because after the president, I can't speak, please.
Ladies
Please
first.
please go ahead. Ladies first.
Okay, I just wanted to remind everyone that we are in the new financial year of the Nigerian Society of Engineers. So from July 1, most people are owing, except people like the past president who is a life member. So if you are not a life member, you're already owing your subscription for the year. I just paid mine yesterday, and I want to urge everybody to pay up their subscriptions in preparation for the conference and AGM in November. Thank you.
Great. That's a
thank you, my boy. I can tell you that some of our members, they paid theirs before yours.
Really? That's great. That's wonderful.
Right, thank you.
Thanks for that vital information. So, President, Engineer.
Yeah, thank you very much.
Okay.
Yeah, Manuel, thank you so much. Thank you for the advertisement for the National Summit. Let me just add that, well, incidentally, I'm the chairman of the Investor Report Card Committee, who is putting together this as part of our mandate. You will soon receive updates on the announcement on the banner with the inclusion of the Honorable Minister of Water of Works and Lagos State Commissioner for Lagos State Deputy Governor, former Commissioner. We also add additional panel discussants, and the fact that the Zoom link is for registration. All those corrections will be made. This was sent out when we found out that we were having difficulties making some confirmation. The Zoom link that you will see, what you're going to start getting from tonight, is the same Zoom link, but you need to register upfront. So I want to thank you and request that expectedly, please share widely, especially in the diaspora, so that we can have as many online. It promises to be quite interesting. Thank you very much.
Great, thank you very much. Yeah, once we get the updated flyers, we will definitely share it widely. Thank you so much for that. Right, so I'll call on the Secretary of the NSC Glasgow branch, Engineer Charles Okafor, who incidentally is a colleague to, I think it's a colleague to the speaker for today, to give the appreciation and vote of thanks. Engineer Charles.
Thank you very much, Dr. Emmanuel. That was quite well managed. And a very special thank you to Dr. Pearce. Obviously, he's professional colleague, and I wouldn't lie to you. The area series of training he has on our intranet, which personally I'm looking at just now, lots of them. So obviously I will be one of those that will be moving from a novice to an well, intermediate or expert. The whole thing depends on how
To a
fast.
Python, to a Python. You are not a Python.
Whichever way, but yeah, I will start moving on from here now. So, but yeah, it was a wonderful presentation and much appreciated. To be frank, personally, I struggle with all these programming, initially.
Yes.
And I noticed that quite a lot has changed, and this is just an area you can't run away with. So lots of programming languages, codes, that are needed today in a different area of engineering. So I believe it's a niche area that as Nigerian and as engineers also we will begin to explore, because at the end of the day, each one of them have its own knock-on effect. It was well presented, and I know we're going away today with series of information. So once again, very much thank you, Dr. Pearce, for putting up this information together. I also want to especially thank each and every one of us that have given a minute or two to be on this program. And the likes of Yinka, you have been an inspiration also. Thank you very much for the wonderful contribution. Everybody's contribution really, really matters here. So whatever thing has been said has been noted, and I believe we can only but improve from here. A very special thank you to those leaders. I can see the VC. You are welcome, sir. And others, branch chairmen that are here. All of you are, much appreciated. I don't think I can overflog this, but thank you and then thank you. Over to you, Dr. Emmanuel.
Thank you very much, Engineer Charles, for that. We appreciate everyone. I see Dr. Adiaga's hand up. Point of order, maybe.
Thank you very much, Doctor. Actually, it's a very quick one. I want to ask Dr. Chris, possibly we could have Android version, because in my school, we use smartboard. So possibly we could have it on the smartboard to teach and also to learn. We can have Android version of this Python.
Okay. Chris? Yeah, okay. Dr. Diaga is asking if it's possible to have Android version of Python for maybe teaching in schools. And he's a head of department in a university in Nigeria.
Yeah, that's a good question. A colleague of mine the other day has an iPhone, and they were showing me a really nice sort of little IDE app on the phone that, and actually it was really cool because it could link to the accelerometer and gyro sensors in the phone, and then you could use that information as inputs to your calculations. Whether there's an equivalent on Android, I would also be really interested in knowing. So I'm afraid I don't have an answer to that question, apologies, but I would hope that there would be something available.
Great, no problem. Thanks so much. I think that's helpful. And for the programmers here, you can think of opportunity in this area, develop the app or whatever. I don't know how it works, but there's opportunity in that area to get something like that onto Android if it doesn't exist. And if anyone knows about that, feel free to share it as well. That'll be helpful. With that, we come to the end of this webinar today. I think we can leave the link open for just general discussions, but officially, this is exactly the where we draw the curtains for this very session of our webinar. I would want to congratulate our branch for holding it out for these 12 months. We've had a single webinar every month for the past 12 months. This is the 12th to close the circle, and we're poised to do even better in the coming year. So thank you all for your cooperation, for attending. Without your presence, we wouldn't have all of these things going on. So thank you for keeping faith with us all the while. We welcome interactions from you. Continue to speak to us through all of our social media channels, of any of all of our social media channels available here. And as I've mentioned in the chat box, the recording from this very webinar would be uploaded to our YouTube channel very shortly tonight, tomorrow, thereabout. go over to the channel and subscribe so that once there's an upload, you get notified about it as well. Click on the notification button. And share it with others who might find this knowledge helpful. Thanks once again, and have a very wonderful evening, I think, wherever you are. And best wishes to all of us for the rest of the weekend and a wonderful week ahead. Thank you so much. I'll leave the link open, just if you have general discussions to make. The EXCO Executive Council members of NSC Glasgow will be having a meeting shortly after this, so just hang on. Thank you.
Yeah, Dr. Adiagad, I think there are a few iDroids that you can use. I think the Quiz side, Beware, and I think there are different ones.